Here is our project for reaction time test. Our goal is to test our reaction and motion time. Our reaction time is calculated by how long it takes the user to tap the image on screen once it appears. Motion time is calculated by how long it takes the user to let go of the button to tap the image on the screen. The image appears randomly on screen each test. We have a button that connects us to ESP32 via Bluetooth and the other starts a new test. We made the app Christmas themed for fun.
Now I will be going over our MIT app code. This is for the reaction time test. This is how the screen will look on the MIT app, and this is how the screen will look on your phone screen. Here we have the Bluetooth status, reaction time, motion time, and instructions. This little tree will act as our button. This is our connect button, our new test button. And down here will be the BLE devices displayed. Right here, the reason the tree is displayed now is because we are doing this on a canvas, so it can move freely and randomly. But since it can move everywhere, it's hard for the MIT app to keep track of the pixels. So it's supposed to be invisible for now since the test hasn't started, but as you can see, we can still see it here. So that's a problem with the MIT app. And this is our block code. Here we have our variables. Most of these are to keep track of the time. This one is to keep track of the byte coming in through the ESP32. And here we have our service UUIDs and the character UUIDs. This is used so that ESP32 can connect via Bluetooth. In this section, we initialize the screen and start some background music. The next few block codes, all these right here, are to connect via Bluetooth. This is our bytes, receive bytes block. When the button is not being pressed, the sprite will be invisible, which is our tree on the screen. And when we press the button, the reaction test starts and the tree becomes visible on the screen. This is just to loop the music once it finishes. This is the start reaction test. The sprite is invisible for now, but it will appear in 1 to 3 seconds. And the timer starts and we sound the bell so it lets the user know. Here we start the timer and the sprite appears in a random place on the canvas. We make it visible and start the start time. This right here keeps track of the time it takes us to release the button. When we touch the sprite, we will get a sound and we will keep track of the time so we could get our motion time and our reaction time. And to start a new test, this is the button and the procedures. The time restarts and we start the reaction test all over again. Thank you. This is our Arduino code. The first few lines include our BLE libraries. This is to check whether the device is connected or not. Our button will be connected to pin 25 on the ESP32. And it will initially be set as it will be at high. So that means that the button will not be pressed. This is our service UUIDs and our character 1 UUIDs, which is for the push button. This is to make sure that the client is connected, which means that ESP32 is connected to the MIT app. Here in the setup, we set the button as an input pull-up. This is so the push button reads as high when it's not pressed. This is our ESP32 name, the name that it's gonna appear on the screen when we're connecting to our device. This is to make the characteristics for the characteristic 1 for the push button. And we start advertising our Bluetooth device, which is the ESP32. In the loop, we read the current button state, and we only send a byte to the MIT app if the button state changes. If we push down on the push button, a byte will be sent to the MIT app letting it know that it's low. And once we release it, it will also be notified. And this line is just to set the state once it's updated, and we include a small delay.